In this lesson, we're going to introduce the idea of the derivative. We've already defined the slope of a curve at a point as the slope of the tangent line to the curve of the point. The slope of the tangent line is found by evaluating the limit of the difference quotient as h is approaching 0. This formula also gave us the instantaneous rate of change of f of x at a point. We summarize these concepts by defining a formula that gives us the instantaneous rate of change and the slope of a tangent line at any point. These two concepts, the instantaneous rate of change and the slope of the tangent line at any point, lead us to the definition of the derivative. So the derivative of f of x is found by evaluating the limit of the difference quotient at any point as h is approaching 0, provided that the limit exists. If the limit exists, then the derivative exists, which means that f of x is differentiable. Some notation for how you can see the derivative described. Most of the time you'll see something like f prime of x, so that little apostrophe, we call it a prime. You might see y prime, or you can even see dy dx. There are actually other notations, but they're not as common. Sometimes you'll see like a capital D and a subscript x is another way of defining the derivative. But these are the main three that I use. Okay, so let's find the first derivative for f of x equals x squared. So as defined, we're looking for the limit of the difference quotient at any point. So I'm going to plug in x plus h squared minus x squared over h. Simplify this. So if you saw the video on slopes of curves, you've already kind of know what the punchline is for this example. Simplifying everything, so I cancel out those x squareds. I'm left with 2xh plus h squared over h. We notice that there's an h in every term, so the h's are going to cancel. I'm left with the limit as h is approaching 0 of 2x plus h, and that's going to give me a 2x. Now remember that this means that at any point on the curve, the slope of x squared is equal to 2x. What this further means is that the instantaneous rate of change of x squared at any point is also given by 2x. So don't forget that this limit of the difference quotient at any point as h is approaching 0 really gives us three main concepts. It gives me the instantaneous rate of change, it gives me the slope of the tangent line or the slope of the curve, and it gives me the first derivative. Okay, let's look at a slightly different example. So let's find f prime of x for f of x equals x squared minus 4x plus 3. So once again, here's my formula, and I'm going to enter all my pieces in. So I use these square brackets to kind of keep that first section, the f of x plus h, separate from the f of x part. So I have x plus h squared minus 4 times x plus h plus 3 minus my function x squared minus 4x plus 3. Simplifying this, so multiplying out that binomial, distributing that negative 4, this is what I'm going to get, x squared plus 2xh plus h squared minus 4x minus 4h plus 3. And then what's nice is we know that that f of x is going to end up canceling with a bunch of the stuff that we see when we multiplied out. So the x squareds are going to cancel, the negative 4x is going to cancel, and the 3 is going to cancel. So I'm left with the limit as h is approaching 0 of 2xh plus h squared minus 4h. Again, there's an h in every term. I'm going to cancel that. I'm left with the limit as h is approaching 0 of 2x plus h minus 4, which gives me 2x minus 4. Last example is we're going to find the first derivative for f of x equals 29. So here's my formula. Well, I have nowhere to put an x plus h in, so really I just have my original function, 29 minus 29 over h. Simplifying that, I get 0 over h, which of course is going to be 0. So in fact, the derivative at any constant is going to be 0. And this result should seem logical because f of x equals 29 is a constant function. And we know that the graph of any constant function is just going to be a horizontal line. Well, the slope of the horizontal line is always 0. So having the limit of the difference quotient equal to 0 should make sense. Hey, just to summarize what we talked about in this little intro video, what is that derivative? Well, the derivative is found by evaluating the limit of the difference quotient as h is approaching 0. And that is provided that the limit exists. So in another video, we're going to talk about what happens when there's a non-existence of the derivative. But if the derivative exists, that means that f of x is differentiable.